Okay, so today we're going to talk about exponential regression. So it was kind of, we've done this before when we did the linear regressions, where we got a table, right? They gave us a table and we would type y1 squiggly line mx1 plus b. Remember that? Okay, so we're going to do the same thing, except now we're going to be doing it with exponential functions, what we've been working on last week. Okay, and do y'all remember what it is? What is the exponential function? What are you supposed to think? What are you supposed to think about?
You're supposed to be smart. Knowledge. Math.
What? I asked y'all one of those questions and you were like, why did you ask us that? Remember? Like, it was a stupid question, but it wasn't really.
No.
Like, it was one of the easiest questions. It was one of the first slides.
No. What's
Oh, okay, wait, no, I don't want to say.
Think about the formula. What is the formula?
MS plus B.
No, it's y equals a plus b.
Not plus.
Times.
So it's y equals a times b raised to the x. Remember, I told y'all to think about the alphabet?
Yeah.
And what were the two letters, the first two letters of the alphabet? A, B, right? Okay? So, now, write that down because that's not going to be on your formula chart. You have to memorize that. You're going to have to memorize y equals a times b raised to the x.
So it's a times b to the power of x.
Yes, y equals a times b to the power of x. And the good thing is, like, if one of these pops up, the answer choice is going to look something like that. Does that make sense?
Yeah.
So it'll remind you. Okay? So I'm going to go over number 3. Okay, so a population of single-celled organisms was grown in a petri dish over a period of 16 hours. The number of organisms at a given time is recorded in the table below. So they give you the table, right? Then they say, determine the exponential regression equation model for these data, rounding all values to the nearest 10,000. Using this equation, predict the number of single-celled organisms to the nearest whole number at the end of the 18th hour. Okay, so I made a Schoology assignment for this, so don't worry about the whole rounding thing. It'll be close to what the answer is. Okay, so you have to open up Desmos. And what is the first thing we did when we did the whole squiggly line thing? What is the first thing you click? Plus, to add a table, right? You have to add a table. Okay, that's the first thing you have to do, add a table. All right, then you fill your table. You have to type all the numbers that go in. So on the X, it's 0, 2.
Mister, okay, now just press enter. Enter again.
Oh yeah, I forgot about that.
That's weird. What the?
Oh, see, no, not 14. We don't need 14. We need 16. Crap. 12
I know that's like 10
and 16.
But
0, 2, 4, 6, 8, 10, 12, 16.
which number are you doing?
Number 3.
Oh.
I said I'm starting on number 3.
Well, okay. Sorry.
Okay? So those are your X's, and you gotta type in your Y's. 25.
You can't do the same thing on that?
46. No. Because it's not linear. So
you give the answer there.
85. 104. 142. And 260. Okay, and if you zoom out, there you see your green dots. Alright. Let me change the x-axis to, let's go to 25. Okay. And let me change this to 0. You don't have to do this, I'm just so we can see it better. So I can show you what it looks like better. Alright. So that's what it looks like. So, when we did the approximation, we did y1. You're going to do the same thing, y1. So y1, and then you're still going to do the squiggly line, right? So that's on the ABC down here. So for the approximately,
Wait, you did one look.
you just type y and then 1. You type y1, remember? You hit Y and then 1, and it does it automatically for you.
Oh, okay.
And then the squiggly line, then AB.
How you make the squiggly line?
It's on the ABC keyboard. AB, and then the exponent raised to the x1, right?
Wait, for AB, I thought you put what, XY. Oh no.
Huh?
For the AB, would
Could
it
be.
put XY?
What do you mean?
Because you know how letters don't work on here?
No, it's AB. No. It's AB. It is AB. This is different because when it's regressions, the letters do work. So AB raised to the x1. Now, when you see this log mode, you have to click it. Click on the thing that says log mode. Okay? You do have to click where it says log mode.
What?
It's like right under it. You see it? You got it? Okay. So 1,000 in decimal is 3 decimal spots, right? 10, tens, hundreds, thousands. So I'm just going to write it how it is. I'm not going to worry about the whole rounding. Okay, so it's Y equals A, which is 27, and then 3 decimal spots, times 1.150 raised to the power of x. So that's the equation, right? Then they ask, using the equation, predict the number of single-celled organisms to the nearest whole number at the end of the 18th hour. Now, the easiest way to do this is we have to plug in 18 for x, right? So we can get a y. Instead of having to type all of this, Desmos already knows what A and B are. A is 27.202 and B is 1.150. So Desmos still knows that, right? They said, okay, A equals this and B equals this. So if you type A, down here it says 27.2025, right? So it's matching what A is. Then if you type B, which is A times B, then it's 27 times 1.15.
But you get 31.3.
Right, but I'm not done because I need to raise it to the 18th power, right? And so then it gives me this answer, right? So 18th, at the end of the 18th hour, the bacteria or the number of organisms is going to be 341.27, but they say whole number, so it's just 341. So y equals 341.
That's crazy, man.
Right? Does that make sense?
Yeah.
Okay, so you don't have to retype. Now, when you go and do the next problems, you don't even have to retype this, right? You don't have to retype this. All you have to do is change the x and y values. Does that make sense?
Yeah.
And then for this, all you have to do is change the exponent, right? Because it's not always going to be to the 18th. Like for number 4, it says the number of bacteria in the colony at the end of 7 hours, so you would put 7 in the exponent. Does that make sense? Any questions about this? This is pretty straightforward. All you're doing is all Desmos. No questions? No questions?
I got
Okay.
that.
So, your assignment on Schoology, or would you rather me just have you round everything, and then if you're wrong, then you're wrong?
Oh no. No, it's not. I like if you have to like turn in the questions. The answers.
You do. But it's a matching, so the answers are going to be there.
Okay.
So you're going to go to worksheets, today's date, with today's assignment. Okay, so for problems 1 through 6, you're going to match the approximation and then the answer. Okay, so you have to match these to these. Does that make sense?
Just 3.
I guess.
Okay, so
Okay,
3 would be
The last one.
this one right here,
G.
right?
Yeah.
Any questions?
No.
No?
Sir, how
Monday.
did you get 18 over?
Because it says,
Oh, yeah.
for number 3, it says at the end of the 18th hour, right? And time is X. It says it on the table. Time hours is X. Okay? So you're going to match. Any questions?
Mister, on number 1, it says the third half is to be reported over a 10-minute period.
Right?
Okay, and luego in the table, acá es, yeah.
So you usually, like, you're just going to type whatever you see for the most part. Okay? Now, be careful because on number 2, if you look at number 2, at the bottom it says using X equals 1 to represent the year 1986. So instead of typing 1986, I'm going to use 1 for 1986. Right? So for number 2, it says using X equals 1 to represent the year 1986. So this means this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9. Right? Does that make sense? Because 1986 is year 1, so then 1987 is year 2.
Oh.
Then 83 is year 3, and year 4, and so on. Does that make sense? Okay. Any questions about this? This is pretty easy. All you're doing is typing stuff into Desmond.
Can you leave that up there?
Yes, I'll leave this up there. Any other questions? All right, go ahead and work on that.